I'm Salim Sarvinejad, a PhD student at New Mexico State University. And in this presentation, I will be presenting the effects of the pomicide in natural pozzolan as a supplement to the cementitious material and Portland cement concrete. First of all, I will be talking about the main goals of the project and why we have performed this sort of experiments. Then I will talk about some basics about this project. And after that, I will provide some information about the methods, materials, and the standards that we have used to do the tests. After that, I will report the results we found, and finally, I wrap the results up as a conclusion. The main goal of this project was to evaluate the ability of the fungicide, this natural pozzolan, to replace fly ash, because we all know that the future production and availability of the fly ash is uncertain. In order to do so, first, we perform some ASR tests and corrosion tests to see how much, natural pozzolan we need to mitigate the ASR. And then in the next part of the project, for the promising mixtures, the mixtures that were acceptable in terms of ASR, we perform some mechanical tests and other durability tests like RCPT, shrinkage, surface resistivity, and freezing and thawing tests. We all know that when harmful ions like chloride penetrate concrete, corrosion is initiated, and it can be happen through four main ways: capillary absorption, hydrostatic pressure, diffusion, and evaporative transport. On the other hand, ASR is an expansive chemical reaction that can produce some internal tensile strain that can lead to cracking and lead chloride and other harmful ions to penetrate more to the concrete. And it can be influenced by alkali content, moisture, and how much siliceous the aggregates are. We have used pomicide, this natural pozzolan made from a pomicide deposit near Española, New Mexico. And we have used fly ash as well, because we all know that at least 20% fly ash is needed to be added to the concrete in order to mitigate the ASR expansion. But as American Coal Ash Association reported, the production of the fly ash is reducing. Like in 2000, 62.5 million tons fly ash was produced, but just 19 years later, in 2019, just half of it, like 30 million tons of fly ash was produced. Here, I'm going to talk about the materials and methods that we have used in this project. This project was divided into two main parts. The first main part was ASR test conducted on mortar bars based on the ASTM-C 1567. 10 to 30% of the cement was replaced with the pomicide, 30% cement was replaced with the fly ash, and up to 40% of the cement was replaced with the combination of the fly ash and pomicide. In another part of this project, as I've already mentioned, some mechanical tests were conducted and other durability tests. For the mechanical test, first we have conducted compression tests based on the ASTM-C 39 and 70 and 28-day strengths were measured for 4x8-inch cylinder specimens. We have also conducted flash short tests based on the ASTM-C 78 and 28-day strength were measured for 6x6x24-inch beam specimens. For our CPT, we have used ASTM-C 1202, and for the surface resistivity, we have used H2T 358, and this test was performed on 4x8-inch cylinder specimens, as you can see in the figures. For the shrinkage test, ASTM-C 157 was used, and for freezing and thawing, ASTM-C 66 and ASTM-C 215 was used. And this test were performed on 3x4x16-inch prismatic specimens, as you can see again in the figures. As a result, first of all, we found that only 10% replacement of the cement with natural pozzolan is not adequate to reduce the ASR expansion below 0.1%, which is acceptable to many transportation agencies for both types of the aggregates that we have used in this project, Placitas and Moriarty. But even in the just majority aggregates, in the right figure, we can see that mixtures with 15% replacement of the cement with natural pozzolan was not, qualified for ASR expansion because the expansion was uh, just marginal and it's about 0.1%. In this slide, we can see that mixtures with just 30% fly ash expansion was much more than the mixtures with 30% natural pozzolan for both types of the aggregates. And it suggests that natural pozzolan can be a good alternative to fly ash in terms of ASR expansion. As I've already mentioned, for the comprehensive results in the left figure, we can see that with increasing the natural pozzolan, the compressive strength decreased for both types of the aggregates. But the more important point here is that the compressive strength of mixtures with 30% fly ash was really close to the mixtures with 30% natural pozzolan. And in the flagship results, in the right figure, we can see that only one mixture modulus of the rupture was slightly less than 600 psi, but was really marginal. And all remaining mixtures in OR was more than 600 psi, which is acceptable to many transportation agencies for both types of the aggregates. So again, we can suggest that this natural pozzolan post-fumicide can be a good alternative to fly ash in terms of both compressive results and flagship tests. Based on the RCPT, we found that all mixtures permeability, chloride ion permeability, was in the category very low based on the HCM12 C12O2. And with increasing the natural pozzolan here, you can see that the permeability decreased and it came closer to the negligible area for both types of aggregates. But the more important point here is that the permeability of the mixture with 30% fly ash was really close to the mixture with 30% natural pozzolan. So again, you can suggest that this fumicide is a good alternative to fly ash in terms of RCPT because the result, the permeability of this kind of mixtures with the same amount of the same percentage of the SCM of what were really close to each other. Well, we have performed surface resistivity tests as well after 2 ages. The first age was 28 days, as you can see in the left figure, and we have performed after 180 days, which we call it later age. In both ages, you can see that with increasing the natural pozzolan, the surface resistivity increased, and it means that the permeability decreased for both types of aggregates. But the more important point here is that in the 28-day results, you can see that mixture with 30% fly ash permeability was much more than the permeability of the mixture with 30% natural pozzolan. But when we did the test after 180 days, we saw that the permeability of the mixture with 30% fly ash was really close to the permeability of the mixture with 30% natural pozzolan. This is obviously can be justified by the slow reaction of the fly ash. But the good point here is that the later age results for surface resistivity and the chloride ion permeability for the mixtures with fly ash and mixtures with the natural pozzolan with the same percentage was very close to each other. And again, the fumicide can be a good alternative to fly ash in terms of chloride ion permeability. For the shrinkage test, we found that the final shrinkage of all mixtures was less than 709 microstrain, which is acceptable to many state departments of the transportation. But with increasing the fumicide here, you can see that the shrinkage decreased for both types of the aggregates. And another point here is that the least final shrinkage was found in the mixtures with the greatest total SCM, which had 20% fumicide and 20% fly ash. But the more important point here is that mixtures with 30% fly ash final shrinkage was slightly less than mixtures with 30% natural pozzolan. It's correct that both of them are, acceptable because they are less than 670 microstring or something like this. But you should be careful when you're using natural polygon in an area that the shrinkage is important, because we know that the shrinkage can be more than the mixture with 30% fly ash. For the frost resistant test, we found that the derivative test, the derivative factor, which is the relative dynamic modules after 300 cycle of freezing and thawing, was more than 78.7 for all mixtures for Pelasitas and Morita aggregates. But the good point here is that mixtures with 30% fly ash derivative factor was slightly more than the mixtures with 30% natural pozzolan, which suggests that when we're going to use this kind of material, this natural pozzolan, in an area that frost resistance is important, we should be careful. But the good news here is that most of them are acceptable because they are more than maybe 80, so we can use them anyway. Here, I'm gonna wrap the results up as a conclusion. First of all, to mitigate ASR, we need at least 20% pomicide, and mixtures with 30% pomicide was the expansion of mixtures with 30% pomicide was really less than the mixtures with 30% fly ash. However, ternary mixtures are suggested to be used to mitigate ASR. So at least 10% fly ash is suggested to be used and added to the concrete alongside with natural pozzolan to have the negligible ASR expansion. For the compressive test, we found that with increasing the pomicide, the compressive strength decreased, but mixtures with 30% pomicide had really close compressive strength to the mixtures with 30% fly ash. So we can suggest that pomicide can be a good alternative to fly ash again. In the flexure test, we found that almost all mixtures, just other than just one of them, which was mixtures with 30% fly ash, the MOR was greater than 600 psi, which is again acceptable to many transportation agencies. For RCPT, we found that the total charge pass based on the ACM C1202 was less than 600 Columbus, which makes them to be in a category very low. I mean, the penetration was very low. And the permeability decreased with increasing the pomicide, and they became closer to the negligible area. And the mixtures with the greatest amount of the SCM, which was 40%, I mean 20% fly ash and 20% natural pozzolan, had the least permeability, colored permeability. For the surface resistivity test, we found that with increasing the pomicide, again, like our CPT, the permeability decreased, and the mixtures with 30% fly ash and mixtures with 30% natural pozzolan later age, permeability was really similar to each other. And generally, we can say that with increasing the total SCM, the permeability decreased, but it's not correct for all mixtures, but generally we can say that. For the shrinkage test, we found that the final shrinkage for all mixtures was less than 710 microstrain, and with increasing the pomicide content, the shrinkage decreased, and the mixtures with the greatest total SCM, which was 40%, showed the least shrinkage. For the freezing and thawing test, we found that the derivative factor for all mixtures was greater than 75, but mixtures with 20 and 30% pomicide was found to have the least derivative factor. And mixtures with 30% pomicide derivative factor was less than the mixture with 30% fly ash. Totally, we can suggest that based on this set of experiments that we have performed this mechanical test, this derivative test, we can suggest that natural pozzolan or this pomicide can be a good alternative to fly ash. And in terms of ASR, RCPT, color ion penetration, corrosion, we can use this natural pozzolan instead of fly ash. Thank you. I'm ready to take any question.